Welcome to Module 4, where we will look at some architectural concepts that will guide you in your designing of AWS environment. The well-architected framework has been developed to help cloud architects build the most secure, high-performing, resilient, and efficient infrastructure possible for their applications. This framework provides a consistent approach for customers and partners to evaluate architectures and provide guidance to help implement designs that will scale with your application needs over time. The AWS well-architected framework helps customers assess and improve their own architectures, all while getting a better understanding of how their design decisions can impact their business. AWS experts have developed several questions to help customers analyze and critically think about their architecture. The framework helps you to determine whether your infrastructure follows best practices. With that, AWS has developed a guide to help you with the design of your architecture from 5 different perspectives or pillars. The pillars are security, reliability, performance efficiency, cost optimization, and operational excellence. Let's go into more details. The security pillar encompasses the ability to protect your information, systems, and assets. It accomplishes this while delivering business value through risk assessments and mitigating strategies. To dive a little deeper here, cloud security is comprised of 5 areas. Let's briefly look into each area. Identity and access management, which is critical to make sure that only authorized and authenticated users can access your resources and only in the manner you intend. There are also detective controls, which can be used to identify a potential security incident by considering some approaches such as capturing, analyzing logs, and integrating auditing controls. Infrastructure protection. This is designed to ensure systems and services within your architecture are protected against unintended and unauthorized access. For instance, the user can create network boundaries, hardening and patching OSs, users, keys, access levels, and application firewalls or gateways. With data protection, there are numerous approaches and methods to consider. Some of them include data classification, encryption, protecting data at rest and in transit, data backup, replication and recovery when needed. Incident response. Even with all the preventive and detective measures, organizations should still create an incident response process to respond to and mitigate any potential security incidents. Incident response is designed to keep your architecture updated to accommodate a timely investigation and recovery. When you are architecting, it's important to consider specific design principles to help you strengthen your security. Apply security at all layers. You want to have multiple layers of defense by securing your infrastructure everywhere and at every layer. In a physical data center, security is typically considered only at the perimeter. With AWS, you can implement security at the perimeter and within and between your resources. This is designed to assist with your individual environment and components that they are secured from each other as well. Next, enable traceability through logging and auditing all actions or changes to your environment. Another useful design principle is the principle of least privilege. Make sure that authorization within your environment is adequate and that you are implementing strong logical access controls to your AWS resources, granting minimal privileges for business requirements. Next, focus on securing your system. With the AWS Shared Responsibility Model, you can focus clearly on securing your application, data, and operating systems, while AWS provides secure infrastructure and services. Finally, automate security best practices. Software-based security mechanisms improve your ability to securely scale more rapidly and cost-effectively. For example, create and save a patched, hardened image of a virtual server so that when you need an image, you can use that image automatically to create a new instance. Another best practice is to automate the response to both routine and anonymous security events. The focus with the reliability pillar is that it encompasses the ability of a system to recover from infrastructure or service failures. It also focuses on the ability to dynamically acquire compute resources to meet demand and mitigate disruptions. The bottom line is that reliability is there to assist in the ability to recover from failures and meet demand. Reliability in the cloud is composed of three areas: foundations, change management, failure management. In order to achieve reliability, your architecture and system must have well-planned foundation in place that can handle changes in demand or with requirements, and also detect failure and automatically self-heal. Before architecting any sort of structure, it is critical to look at the foundation before construction. Similarly, in the cloud, before architecting any system, foundational requirements that influence reliability should be in place. With change management, it is really important to fully understand and be aware of how change can affect your system. If you plan proactively and monitor your systems, you can accommodate and adjust to change quickly and reliably. To really make sure your architecture is reliable, it is key to anticipate, be aware, respond, and prevent failures from happening. In a cloud environment, you can take advantage of automation with monitoring, replace systems in your environment, and later, troubleshoot failed systems all at low cost, and all while still being reliable. The design principles that can increase reliability include testing recovery procedures. In the cloud, users have the ability to test how systems fail and can validate their recovery procedures. Users can simulate and expose different failures and then rectify before a real failure occurs. Automatically recover from failure. In AWS, users can trigger automated responses when thresholds are breached. This makes it possible to anticipate and remediate failures before they occur. Scale horizontally to increase aggregate system availability. When you have one large resource, it is beneficial to replace that large resource with multiple small resources to reduce the impact of a single point of failure on the overall system. Scale horizontally and distribute requests among the multiple small resources. Stop guessing capacity. In the cloud environment, you have the ability to monitor demand and systems utilization, and automate the addition or removal of resources. This is designed to make sure you have the optimal level to satisfy your demand without over or under provisioning. Manage change in automation. Changes to your architectures and infrastructure should be made using automation. With this, you only need to manage change through your automation, not every single system or resource. Now let's look at the performance efficiency pillar. The four pieces that make up performance efficiency in the cloud include selection, review, monitoring, trade-offs. Let's dive deeper into each area. With selection, it is important to choose the best solution that will optimize your architecture. However, these solutions vary based on the kind of workload you have. With AWS, resources are virtualized and allow you to customize your solutions in many different types and configurations. With Review, you can continuously innovate your solutions and take advantage of the newer technologies and approaches that become available. Any of these newly released services or features can improve the performance efficiency of your architecture. With regards to monitoring, after you have implemented your architecture, you will need to monitor performance to verify that you can remediate any issues before customers are affected and aware of them. With AWS, you can use automation and monitor your architecture with tools such as Amazon CloudWatch, Amazon Simple Queue Service, and AWS Lambda. Finally, there are trade-offs. An example of a trade-off is trading consistency, durability, and space versus time or latency to deliver higher performance. Now let's look at the design principles that can help you achieve performance efficiency. First, democratize advanced technologies. Technologies that are difficult to implement can become simpler to consume by pushing that knowledge and complexity into the cloud vendor's domain. Instead of having your IT team learn how to host and run the new technology, they can consume it as a service. Then you have going global in minutes. With AWS, you can easily deploy your systems in multiple regions around the world while providing a lower latency and better experience for your customers at minimal cost. The next design principle that can help you achieve performance efficiency is to use a serverless architecture. In the cloud, you remove the need to run and maintain traditional server for compute activities. This also removes the operational burden and can lower transactional costs. Another design principle is to experiment more often. With virtualization, you can quickly carry out testing to enhance efficiency. Finally, there's mathematical sympathy. This principle has suggestions to use the technology approach that best aligns to what you are trying to achieve. Essentially, use the tool or service that best suits your needs. Our next pillar is the cost optimization pillar, which includes the continual process of refinement and improvement of a system throughout its entire life cycle. This pillar encompasses the idea that you can build and operate cost-aware systems and maximize its return on investment. The four areas that make up the cost optimization pillar include cost-effective resources, matching supply with demand, expenditure awareness, and finally, optimizing over time. A fully cost-optimized system will use all resources it has to achieve the best outcome at the lowest possible price point, all while still meeting your functional requirements. Making sure that your systems are using the appropriate services, resources, and configurations is one of the key parts to cost savings. As a user, you want to focus on the details such as provisioning, sizing, purchasing options, and other specifics to design the best architecture for your needs. Another component to cost optimization is matching your supply with your demand. With AWS Cloud, you can leverage the elasticity of the cloud architecture to meet demands as they change. You can auto-scale and be notified by other services to adjust your supply due to demand changes. Then, we have expenditure awareness. Being fully aware and cognizant of what spending and cost drivers are happening with your business is critical. Having the ability to see, understand, and break down the current costs, predict future costs, and plan accordingly only enhances the cost optimization of your architecture in the cloud. Finally, in AWS, you can optimize over time with all of the tools and different approaches. You can measure, monitor, and improve your architecture from the data you collected in the AWS platform. Adopt a consumption model. With a consumption model, you pay only for the computing resources you use and then increase or decrease depending on business requirements. Essentially, trading CapEx for OpEx. The next principle is to measure overall efficiency. It is important to measure the business output of the systems and costs associated with delivering it. Then take this measurement to understand how gains are made from increasing output and reducing costs. Stop spending money on data center operations. With AWS, you no longer have to do the heavy lifting of racking, stacking, and power servers. We take that burden so that you can focus on your customers and businesses and projects instead of the IT infrastructure. Next, analyze and attribute expenditure. With the cloud, it is so much simpler and easier to accurately identify the usage and cost of systems. Customers can measure their return on investment, which provides them the opportunity to optimize resources and reduce costs. Finally, we suggest customers to use managed services to reduce the cost of ownership. The cloud has provided many managed services to remove the operational burden of maintaining servers for tasks such as sending emails or managing databases. And since this is all done on a cloud scale, they can offer a lower cost per transaction or service. The operational excellence pillar focuses on running and monitoring systems to deliver business value and continually improving processes and procedures. Key topics include managing and automating changes, responding to events, and defining standards to successfully manage daily operations. In summary, here are the 5 pillars that make up the AWS well-architected framework. We have come to the end of Module 4. Please test your knowledge with these questions.